Okay, friends, if anyone has any old homeworks, just come put it in the orange folder. Make sure your name's on, please. So, I thought yesterday that was kind of cool. That was kind of a little gift to y'all. Thank you. Being that this semester has had winter 7 times during it, spring 4 times, summer once. But hopefully that kind of equalized some grades a little bit, which is good. A couple of yous, and some of you, if I repeat your name, if we've already talked, I'm sorry. So Olivia will take care of that capstone. You said Cooper's not here. Grant, not here. Lieb, capstone. Cool. And Yasmin, we talked. We'll take care of that. Angela Munoz, capstone. Can you come in on one of your off periods to see me? And we'll have you do it. Cool. And Ben, you got it still. And Michael, you still have that. Yes. Peyton, you got it. We talked. Yep. Parker, we talked. So all you need is a 6. You get a 6, you get a 20 out of 20 on a quiz score. So that's kind of cool. But I just want to make sure we get it done. What I fear with the capstone is 2 things. For at the sophomores, juniors, seniors don't. Seniors, but juniors don't have to worry about it. I would just hate for, if you are a sophomore, 2 years from now, that I have your counselor hammering me saying, hey, this kid hasn't passed the math capstone for Algebra 2. I think it's sometimes silly, where it's like, I'm on track with stuff, but there are certain things that slip through, and then all of a sudden it becomes an emergency for someone that needs something to graduate. It's like, dude, I did everything I could. But, and of course, 2 years from now, if you were that sophomore, I would be happy to have you come and redo the capstone with me and do all that kind of stuff. But let's see. But everyone's good? I thought you guys worked well together as groups. That was fun watching you guys yesterday. Yeah, there was a lot of...
stressed me out at the end.
Yeah, at the end we were like, oh no.
And why did you give it to me? The biggest ball of literal anxiety. Everyone crowded around me and it was so not okay.
Oh, I'm sorry.
It's okay.
Someone give Peyton a hug.
No.
All right, Peyton, give yourself a hug.
He's really going through this right now.
Oh, thanks, Kate.
No problem.
Yeah. So we have one last unit. Oh, come see me for that last capstone. So we
all right, yeah, totally.
Thanks, man. We have one last unit, and it's on sequences and series. And this is something that's used a lot in pre-calc as well as calculus. And some of you, I know, say, oh, I'm just taking college algebra. Sure, I get it. But just because you didn't take pre-calculus or calculus in high school doesn't mean that you might not have that opportunity in college. And the thing that comes down to things that make me laugh are, when I was your age, I had like 19 things I wanted to do for my career, and not one of them was being a teacher. And I don't regret being a teacher. I love what I do, so I'm really happy I found this career. But when people are like, oh, I know exactly what I want to do for the rest of my life, it's like, wow, really?
Yeah.
So that's pretty cool if that's you. But realize this, a lot of you will change what your degree is if you go to college, and a lot of you will change jobs and careers quite often. What would I want to do in place of this? I want to be a fireman. And not because I want to go out and help people. I just think fire trucks are cool. I'm just that boy. So, if you one day when you're 10 years from now when you drive by a creek and you see a fire truck out in the parking lot, you have to stir up Gunner's fire truck. So, yeah, I think that'd be kind of a good gig. But sequences and series it's a different math to think about. It's not a difficult thing to think about. Fortunately for you all, you will not quiz on this, but it will be on the final. My plan is, today's Thursday, right?
Yeah.
I'm not losing days. Okay, so Thursday, Friday, Monday, Tuesday, and we will be done with, by the end of Tuesday's class, done with the Algebra 2 content. And then Wednesday, Thursday, Friday, we'll be doing any stuff about the review that you might want to go over. So you know that there's a large review packet at the end of your book. If you don't have it for whatever reason, or if you don't have a book, it's, go on to Schoology and print it. Yeah.
Is it just this semester on the final, or is it the whole year?
Yeah, well, some of the numbers we saw last semester, like 5 and 6 and 12, you might see again. But it's basically just this year.
Nice.
I mean, there are certain skills that you built into that will probably continue. I mean, you saw yesterday, like with the graphing parabola. I think the one that had the most questions on it.
Statistics on the final?
A little bit. So, unit circle, yeah.
Unit circle's so easy.
So, if you do happen to owe me the capstone or any of the other quizzes or tests, hang on a second. Excuse me. Let's make sure we try and get it made up. I mean, I'd hopefully get everything made up by Friday of next week. Because though I love seeing you when we're putting finals in, I don't want you to come rolling in saying, hey, I have those 3 tests that I owe you. Man, it's Thursday in 2 weeks, and grades are due like in 20 seconds, and you're here to make up 3 quizzes. Though I would go to bat for you saying, hey, this kid needed to make some stuff up, and then of course I get badgered by the registrar saying, well, why wasn't it made up during the semester? And then I get to make up stuff saying like I'm a really bad, ineffective teacher and things like that. And it was my fault that the kid didn't, and I didn't realize they weren't in class and they weren't doing the test and things like that. So it's that's just all sarcasm. So I would think for you all, you have 4 homework assignments left. The review, am I going to collect it? I really don't think I am. And I'm not saying that because I'm not saying you shouldn't do it. I mean, if you're like, hey, I did it, I should get points. Okay, fine, I'll give you points. But why don't I'll create a review column, and if you happen to have the review done on the day of the final, just come up and show me, and I'll have it as a 10 out of 10 homework assignment. And if you didn't do it, I'll just exempt your grade so it doesn't count against or for against you.
Nice.
Okay, so for those that are wanting the points, okay, we could put it in there. But for those of you who are like, I'm not too stressed. So probably later today you'll see in the grade book 6 more columns. You'll see the 4 homeworks that come out of this. You'll see the review column, then you'll see the final exam column. They'll be blank as we go through, but basically what I put in today will be the last, you'll see the last of the scores. So you'll see that, oh my gosh, I have 280 things already in and 6 things left. The final exam does indeed count for 20% of the grade. We are not putting on the final stuff. That's going to be the trick stuff. I mean, a lot of times finals don't go as deep as we would have gone on a normal unit test or quiz. So I'd say, definitely look over stuff. Make sure you're good with stuff. Make sure you're asking questions on those review days. Make sure you feel comfortable with it. And please know, yes, I am available. Come in and get help from me. Yeah.
Are you dropping out of quiz?
I don't know. I haven't had my PLC yet. It got canceled this morning. And of course, I told everybody that wanted to come in this morning, no, I have a PLC, and then I find out this morning that it's canceled. I can't decide like weeks in advance on this stuff. I don't know.
They should have got on the snow day.
If we got a snow day, that would have killed one of our review days. So I'm kind of happy we didn't, for your guys' sake, because I want all of you to be able to get the grades that you deserve. Not, dang, if I just had one more day, I could have had a higher grade because I would have understood that content a little bit more. So, does everyone have a packet of notes? We're good to go. All right. So there are 2 different sequences and series that we're going to deal with. We're going to deal with arithmetic, and we're going to deal with geometric. Okay, geometric will be tomorrow. And then we do the summation, like what does the series go to, things like that. It's related to linear equations, stuff like that. It's just a different way of looking at it. Okay, so these start out pretty simple, and they don't really get unbelievably hard. I mean, you're kind of looking for the pattern. So on the very first one, it looks like each of them are adding by 2 each time.
Get a happy birthday. What the hell is this?
We still don't know who Jimmy is.
Thank you.
Oh, well.
We haven't figured out Jimmy yet.
Who wrote this?
I don't know. That was me with the notes, but I don't know who wrote the board.
Dude, it's the guy who owns the Subway shop. Jimmy John.
Oh, Jimmy.
Jimmy John.
You're right, Sam.
That's wrong.
All right, so that very first one looks like I'm adding 2 each time. Would you agree?
Yes.
So 8, 10, 12. Woo, that's tough. Woo, man. Do you want me to go over one more time? What about the second one, Doug? What does it look like is happening? We're subtracting 5 each time. So -10, then -15, then -20. Toughest stuff you've ever seen. The third one.
Adding 1 to the denominator and the numerator.
Yeah, that's all we're doing. We're just adding 1 to the denominator and numerator. So I get 4 over 5, and then I get 5 over 6, and 6 over 7, and 7 over 8. And then the numbers are ordered so that it's first member, second member, third member, so on. Okay, we can actually find the 0 member, the precursor. So right here, this would be the 0 term. This would be, if I put a 15 here, and then this one I believe it would just be 1 over 2, so it would be 0 over 1, which would be just 0. So there is something called, there's going to be things you're going to hear is like me saying the nth term, which is we're trying to find a term that's somewhere in there. There's sometimes the first term, which is a sub 1, where you have an a with a little 1. And sometimes you have an a sub 0, which is the 0 term. And all that really means is you're plugging in a certain number in 0, 1, 2, 3 in order to get those. Anyone lost yet?
No.
Numbers in the sequence are called terms. Ooh, that's tough. Function whose domain is a set of consecutive integers is a sequence. If a domain is not stated, it is understood that the domain starts with 1. Okay. So domain, we've been dealing with the domain having a lot of negative, positive infinity, but if we don't have a domain stated, we think that it starts with 1. All right. There we are. All right. Give the relative position of each. The first term we're going to call a sub 1. The second term a sub 2. The third term a sub 3. That goes along with the domain. The terms in the sequence are kind of the range of it. And so I don't know how important this information is. Just kind of just getting the schematics of it down. And then a sequence with the last term is called a finite sequence. So if you had 2, 4, 6, 8, 10, and it stops, this is finite. It stops. Okay? It ends. If you saw something that looked like this, it's the exact same numbers, and then it has ... that means it's infinite. It keeps going. It keeps going. Okay? That's supposed to say going. But sorry, my handwriting's getting bad. Must be right with my left. Pretty simple still?
Yeah.
All right. So first term of sequence 1 is a 5. Term 2 is a 10. Term 3 is 15. Or we could say a sub 1, a sub 2, a sub 3. Which sequence is finite? Yeah, it's this one because it doesn't have the ... and the infinite one because we have the ... And then what rule would represent the sequence? Yeah, it looks like we're adding 5 each time. Where we'll use a term that we're going to see soon. It's called common difference. Is adding 5 each time. Okay? Still okay? All right. Man, when's this stuff going to get tough? I don't know. All right. So use the rule to write the first 6 terms of the sequence. Now, this is where when people look at it, it's like this is the most complex thing in the world, but this is all it is. Ready? So I'm going to start with 1. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. And all this means is I'm going to take 1 and plug it in, 2 in, 3 in, 4 in, and then do the math. 2 times 1 is 2. That's 5. That's going to give me 7. That's going to give me 9. That's going to give me 11. So then this one I could just, I don't even have to do the math. That's 13. The last one would be 15. What are we doing each time to it?
Just subbing in the numbers.
Yeah, but as I go through the end thing.
Oh, it's common difference of 2.
Yeah, common difference of 2. Cool. Okay. And then the second one. The second one, they have it kind of written this way. So we're going to look at f at 1, f at 2, f at 3, f at 4, etc. So this would be negative 2 times 1 minus 1, so that's 0. And then it's going to be negative 2, 2 minus 1, which is 1. And then negative 2, 3 minus 1, which is 2. And then negative 4, I have negative 2 to the third power, because I'm plugging 4 in. So a number raised to the 0 power. Oh, no. Logan was in Algebra 1 yesterday when I ripped him.
What?
I'm so, like, literally, like, 19 times going in. Like, y'all know this is 1. But I'm like, same problem over and over. Okay, what's this? 135. Where the hell does that come from? Oh. Like, well, we just don't get it, Mr. Stirrup. It's not like it's the first day. All right. Hey, negative 2 to the first power is? Negative 2. And this is grouped, right? So negative 2 to the second power is? 4. And then this is grouped again, so that goes to negative 8. It keeps going. If I went 5, 6, I'd get to, keep going with the number. So I'd get positive 16 and then negative 32. So sometimes it goes back and forth between positives and negatives. And question number 5 right there in the blue doesn't have a common difference. It has a multiplier, so that's going to be a little different sometimes. Other times on this one, it's like, oh, I'm adding 2. I have common difference 2 of my sequence. Still okay? Mm-hmm. All right. All right, so a sequence in which the difference between the consecutive terms is constant is called an arithmetic sequence. So, and then the constant difference, D, is called the common difference. And we're going to start using D as the common difference. So when you see the general form, when you see D, that's referring to the common difference of our sequence of events. All right. To decide if a sequence is arithmetic, I need a common difference. I need a common difference. I probably need my first term. Does that seem okay? All right. Decide if the sequence is arithmetic. So it has to have some sort of common difference. So if I go 1 minus 3, I get 4. 5 minus 1, I get 4. 9 minus 5, I get 4. 13 minus 9, I get 4. So what's my common difference on this one? 4. So I told you arithmetic has to have a common difference. So is this arithmetic?
Yep. Yeah.
And then let's look at number 7. So 5 minus 2 is 3. 10 minus 5 is 5. 7, 9. It's definitely some sort of pattern to this. But is it a common difference? No. So this is not arithmetic. And that one is. Are these, both of those listed, are they both finite? Were they both infinite?
Infinite.
Why? The dot 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 means the pattern keeps going. Okay? All right. How can we write rules for arithmetic sequences? Okay, well, things that I would feel comfortable saying. I know that my first term is 5. So that means that I plugged 1 into some kind of equation and I got 5 out.
Yes.
Okay? If I plug 2 into the equation, I'm going to get 8 out. If I plug 3 into the equation, I'm going to get 11 out. Okay? And then, do I have a common difference between these? Yeah, so they increase each time by 3, so I have a common difference of 3. I have to go grab something next door, so I have to make sure I say this to you correctly. I had written down some notes and I forgot to bring them to class. Where are we at? There we go. All right. So, common difference 3. First term is this. So I'm going to use this equation. A sub n equals a sub 1 plus n minus 1 times d. That's on your slide? Next slide? Oh, okay. Okay, so this is the equation we're going to use. So if I wanted to make the equation up, do I have at least 2 of the variables in that blue equation?
Yes.
I have a sub 1 and I have d. Okay? So I'm going to say that my nth term equation is going to be 5 plus, and then I have n minus 1 times d is my common difference. Okay? So I have that. So let's see if we can make our sequence happen with what's up on the board. Okay? So if I know what a sub 1 is. It is 5. But let's just verify this. So I'm going to go 5 plus 1 minus 1 times 3. 1 minus 1 is 0. 0 times 3 is 0. 0 added to 5? 5. Okay, that works. Let's see if my second term works. So I'm going to go 5 plus, what am I plugging in for n then? I have a sub n. That's an n, that's an n. So I'm plugging a 2 in there, agree? 2 minus 1? 1. 1 times 3? 3. 3 added to 5?
8.
Is that what our second term is listed up there?
Yes.
Do you think it would work with 11? I think
Yeah.
so.
I assume.
And it's an infinite series. So this is our equation. This is our equation to our infinite series of that. All right, let's do the same thing for this next one. So I'm going to still use that equation. A sub n equals a sub 1 plus n minus 1 times d. And just so you know, on the final exam, that will be one of the equations that will be given to you. Okay? So don't be like, yeah. I might not put next to it arithmetic different sequence.
So are we getting a bunch of equations on the final then?
There's like an equation page that is just going to be handed to you as a loose page that you can use as scratch paper.
Okay.
There might be some equations on there you might not use.
But they're all going to be there.
We were doing this final equates to the last final. It's way harder.
In your case, yes. But,
Cool.
well, I'm giving you the real hard one. Everyone else gets where all the
Yeah, because
answers are
somehow
A.
you got a good grade on the last one, so he has to give you a hard one. This is different.
Yeah.
Yeah.
Has to give you a different one.
Or he's got something hanging out of his face.
Yeah.
Like, don't look at me, don't look at me. All right, hey, what does it appear my first term is on this next one? So a sub 1 is 8.
-5.
And you're saying -5, so I'm subtracting 5 each time. So my common difference is -5. So do I have enough information to plug it into that given equation?
Yes.
I do. All right, so I think I could say that my nth term is 8 plus n minus 1 times -5. That okay? Okay.
Yeah.
Let's see if this does work though. A sub 1 is 8 plus 1 minus 1 times -5. 1 minus 1 is 0. 0 times -5 is 0. My first term is 8. It works. Let's see if it works on the second one. A sub 2. So I'm going to go 8 plus, and I'm going to go 2 minus 1, because I'm plugging 2 in this time, times the -5. Let's make sure that works. 2 minus 1 is 1. 1 times -5 is -5. 8 minus 5. Let's make sure I get that on my third term. A sub 3. 8 plus 3 minus 1 times -5. 3 minus 1 is 2. 2 times -5 is -10. 8 subtract 10. -2. Is this our equation?
Yes.
Sure is. Sure is.
Heck yeah.
All right. The rule for arithmetic sequence, the nth term of an arithmetic sequence is the first term, a sub 1, and the common difference given by, and there's two different equations they have up there. Notice one of them is starting at a sub 0. So we don't necessarily have the very first term, but if we have the common difference, or the 0 term, but we can find the 0 term. Something to look at. Let's say we had this as our equation. Let's go with, let's go back. Let's say we had 12 plus n minus 1 times 6. So you might come across a problem that says, hey, what is the 50th term? So what would you have to do? Plug in 50. Okay, so you're going to go 12 plus
What are we in algebra 1?
50 minus 1 times 6. So that's going to be 49 times 6. 49 times 6, whatever that comes out to, we're going to add 12 to it. And that'll give me my 50th term of my sequence.
294.
That's 294? How much?
I don't know.
I don't know. Sam, you got a calculator going?
Pretty sure it's 294.
Sort of.
49 times 6?
Yeah, it's kind of stuck on something. I don't know how to get it off.
294, add 12.
Someone put it on a game. I don't
How much?
know to get it.
Someone put it on a game, you can't get it out. Mine's better than the calculator, Sam.
How does the world of Texas Instruments, when you guys have the coolest games in the world on your phones, you get to play against each other, you can't figure out Black Dude on there?
Mr. always playing my games or something on my calculator.
Oh, I got out. I just had to press exit.
Why would you leave? Play Block Dude, that's the best one.
Yeah, I'm on level 3 though. I'm stuck.
How'd you get that on your calculator?
I don't know.
It usually came on them.
It
And
comes
then,
on as standard, and then Miss Nye or Mr. Armsby uses it.
it's just, you don't need this. It's like, what am I going to do during class
Yeah,
now? I don't know,
exactly.
learn.
What am I supposed to do now? I can't play Block Dude in the back of class.
Block Dude is awesome.
Block Dude is awesome.
Hey. All right, Cam.
I think the counts.
Yeah.
No. Yeah.
All right. Does this look like I'm subtracting 6?
Yeah.
Looks like it.
No.
So a sub n equals a sub 1 plus n minus 1 times d. Agreed?
Yeah.
And freeze.
Freeze at 666.
Wait, how do you go back to the game?
Go to program, or go under the apps, APPS. I think it might be under there.
Oh, programs.
And games maybe?
Cameron, you haven't taken it yet, have you?
No.
Okay.
Me calentó todo.
Do we still need to do the review online? If we haven't?
Yeah.
Yes, please.
So I take the capstone now?
Cameron doesn't have his classes period, so he's allowed to.
Well, neither do
Are you going in as a grade?
Huh?
Cooper, if you're taking are you going in as a grade?
Yeah.
How many points?
All the points.
Cameron, you ready for the code?
You're so good. Yeah. I just choose.
I'll bring it up for you. That's easy enough. Don't worry. All right.
Yeah, I don't know.
All right. They want us to find the 25th term. So a lot of students, when they get stuck on this, they will write out 21 more dashes and keep subtracting 6.
You're kidding.
But for us cool kids, we know that our first term is 50. Our n minus 1 is fine. And then my common difference is negative 6. So if I want to find the 25th term,
It equals 195 or negative.
how much?
Negative 194. How do you know?
No,
It equals
it's negative 94.
I don't know. I guess.
So it's negative. Did you do the whole math? You added 50 to it as well?
It's negative 94.
Negative 94?
Yeah.
Sweet. So 24 times negative 6 gives me a negative number, and then add 50 to that negative number, it comes out to negative 94. I like it. All right.
It goes up by 0.66.
Okay. So in this, I like that you're seeing that. So 0.66 means you're adding 2/3, it looks like.
Yeah.
So if you saw something like this, what's sometimes tough about this is like, wait, I have numbers, and then I have fractions, then I have some numbers. So on this one, if I made this a denominator over 3, I would make that 9/3, because it's 9/3 the same thing as 3. And then this one, I would actually make it 15/3. And so it looks like our common difference is 2/3. We're adding 2/3 each time. So all I did was I just got it to be a common denominator. So now we can go ahead and do our nth term. So my first term is 9/3, so I'll just put 3 because that comes out a little simpler. N minus 1 times 2/3. And we still, on this one, wanted to find the 25th term, I believe.
Yeah.
So a sub 25 equals 3 plus 25 minus 1 times 2/3. So that's 24. 24 divided by 3 is 8. 8 times 2 is 16. 16 added to 3 is 19.
Boom.
I think that works. Cameron, let me know when you're ready. That one's frozen again, too? Whew.
Unlucky, dude. I told you you couldn't take it, man. I don't know why you didn't listen.
You jinxed it. I'll just find it.
Drew's over there, looking at, different websites.
I wouldn't even want to. I'm making sure nobody else gets on the Wi-Fi.
He's got the blocker on. Sorry about that, bub.
That'd be so funny.
All right. So, one term of the arithmetic sequence is a sub 13 is equal to 30, and the common difference is 3/2. Okay, so the general equation is a sub n equals a sub 1 plus n minus 1 times d. Agreed? So, they gave us the common difference, but then they gave us the 13th term. So I'm going to plug this in. A sub 13, a sub 1, we don't know, plus n minus 1. Actually, that's going to be a 13, excuse me. That's going to be a 13 minus 1, and our common difference is 3/2. Is that okay so far? So what did we find that a sub 13 is equal to? What did they tell us it was equal to?
30.
30. So I'm going to change this to a 30. And by me doing this, that's going to allow me to find my first term. When I find my first term, it'll allow me to go back and find my nth term. So that's going to be 12 times 3 over 2. So 12 over 2.
You keep the 13.
Do what's that?
You keep the 13.
Yeah, because that's the 13th term, so I want 13 minus 1 to get 12.
Okay.
Okay, so 12, that's 36 over 2, that's 18. So a sub 1 plus 18. Algebra 1 looks like it's going to be 12, right? So a sub 1 is equal to 12. So my nth term, I'm going to have my first term, which I just found is 12, plus n minus 1 times 3 over 2. So this is my nth term equation. This is the equation that I could use. So they could give you a term and they could give you a common difference, and you could go figure that out. We doing okay on notes?
Yeah. I wish we took this test instead of the chapter. Actually, no. Anyway.
Yeah, you guys did well. You guys did well. Not sure how you got the answers, but you did well.
I wonder.
All right. Moving on. All right. This one, they tell us the 12th term is -4, and we have a common difference. So I have a sub n is equal to a sub 1 plus n minus 1 times d. So I know that my 12th term is that. So I'm going to go 12 minus 1 times -6. I know that a sub 12, they told us, is -4. That's 11 times 6. So that's going to give me a sub 1 equals -66. Add 66 over here. So I'm going to get to 62. So my first term is 62. And then I can go ahead and plug that back in. I can take this, plug it back in here, and I already knew my common difference. So I have a sub n is equal to 62 plus n minus 1 times d, which was -6. And there's my nth term equation. So it's a linear equation if you look at it, because your n acts like x. Your x is raised to the first power, or your n is raised to the first power. All right. What are your thoughts on this one? I have the 6th term being 10. I have the 21st term being 55.
Ooh.
Oh, I'm
15 divided by 45 is going to be 3.
All right, so I'm going to just write this up, see if we can figure this out. A sub 1. What?
D is 3.
How do you know, bro?
D is 3?
Yeah.
So I would look at this way. I'd go 55 minus 10, which is 45. And if I go from a sub 6 to a sub 21, how many spaces are in between that? So I had a sub 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I got 15 spots. There's 15 spots. Like I would move over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 movements.
3.
So what? So my common difference.
D
I said
is
that 3.
Yeah, good.
Go.
I know you did. I just wanted the rest of the people to catch up.
Well, you can just subtract 21 and 6
I
and
understand.
then divide it.
Nice.
Cool. There you go. So D equals 3. So now we know that D equals 3. I'm going to have to pick either a sub 6 or a sub 21. I'll pick a sub 6. So I know a sub 6 is equal to a sub 1 plus n minus 1 times my 3. I know a sub 6 we knew it was 10. A sub 1 plus 6 minus 1 times 3. 6 minus 1, that's 15. So I'm going to get this. So my first term is this. So then my nth term is a sub 1, which is -5, plus n minus 1 times my d, which was 3. There's my nth term. Did I get done?
Max Transman wrote my name in enough
I
times.
have one left. I think you had enough to go off that. Yes?
Yes.
All right.
They're up.
So being as it's at the end of the semester, I bet you guys want a ton of homework, don't you?
Yep.
Yeah.
Cool. Yeah.
Found it, Nathan. Give me some
Are we
points.
doing all of it?
Who asked for all of it?
No.
Who said no?
Let's do them all on a separate sheet of paper twice.
We should just play block dude for our homework.
Do it once. And then
Let's do even.
10.
I wish high level
Hang
thing
it.
is
Look at that. Stop. Worksheet. Killing me. Give me that.
Can't write the homework if nobody can see it.
Worksheet 10A odds.
10A. Wait, 10A?
10A. It's chapter 10. We went backwards.
Wait, all of it?
Odds.
Hold on, bro.